Hi, my name is Gull. I work with Juniper Networks in the Education Services Department. Today I'll be sharing a Learning Byte related to the Zero Touch Provisioning or ZTP feature available on the EX and QFX Series switches. The agenda for this Learning Byte includes an overview of the feature as well as a working example. Before we get started in describing the Zero Touch Provisioning feature too much, let's talk about the basic requirements and tasks involved in deploying a switch. When you go to deploy a switch, you typically rack and cable the switch, and then you perform the initial provisioning tasks to make that switch operational. So there's two parts of the equation: rack, stack, cable, and then the manual provisioning efforts. Once both of these things are done, and if they're done correctly, then you have an operational device. Now, as it stands, this seems like a fairly simple and straightforward process, right? So what about when you're deploying dozens or perhaps even 100 plus switches in an environment? The rack, stack, and cable part of the equation doesn't really change. That's going to remain constant. The manual provisioning effort, that can get a little hairy. A number of issues could potentially be introduced in that situation, and it's going to take a lot of time to do the provisioning and then to work through the potential issues that are introduced through that manual provisioning step. So this is where zero touch provisioning comes in to save the day. So zero touch provisioning is a feature that allows automation as far as the provisioning, the day one provisioning tasks. This can help increase the speed of deploying those switches and provisioning those switches, and if done correctly, it can reduce configuration errors in the end. So what does it actually do? ZTP, or Zero Touch Provisioning, automates the day one provisioning tasks, including the software image verification and upgrades as needed. It also locates and applies the desired configuration files for the switches being deployed. So how does it work? Well, there's three basic steps or phases involved. The first phase is getting the switches, the EX or QFX switches, onto the network so they can communicate with the server holding the software image and configuration files. So the switch will discover the DHCP server and obtain an IP address and some other key details that are passed along through DHCP options, and we'll discuss that more here in just a moment. It will then verify its software version, make sure it's the correct version for the network, and if it's not, it will retrieve and upgrade the software image so that it's compliant with the network. The next thing it does is locates and applies a configuration file from the server. So looking at this in a bit more detail, you have the switch that is racked, stacked, and cabled. As long as it has the factory default configuration, it will begin the DHCP discovery process where a request and reply is performed there. Once it gets an IP address, it joins the network and can then communicate further with other devices on the network. In that DHCP communication process, the switch or switches receive details and instructions by way of DHCP options, and it's through those DHCP options that they know about the storage server, the transfer method, whether it be FTP, HTTP, or TFTP. If a configuration file is not listed in those options, or a software version is not listed, then it's going to remain as it is. It's going to keep the software version the same, and it's going to run the same default configuration and essentially just end the ZTP process, and we'll see that here in just a moment. So using DHCP option 43 and specifically sub option 0 or suboption 04 within option 43. The DHCP server can inform the switch of the software image that is required on the network. If the switch is already running that version, then it moves on to the next phase. If it's not running that version, it will then proceed to download the software image from the storage server and then perform an upgrade. DHCP option 43 with the sub option 3 is the method used to inform the switch of the transfer mode, again whether that be FTP, HTTP, or TFTP. If no option is specified within that sub option, it defaults to TFTP. And then DHCP option 150 or 66 is the option used to inform the switch of the storage server's IP address. Okay, the next phase is once it's upgraded, it can locate and load the desired configuration for that device. Similar, it's going to look at option 43 sub option 3 to identify the transfer mode, and option 150 or 66 to identify the IP address of the server. And again, if no configuration file is referenced in the DHCP option, then the switch will retain the factory default settings and simply end the ZTP processing. The end result is you've got switches that were added to the network with their factory default configurations, and at the end of the process, assuming everything's put in place correctly and configured correctly, you've got switches with customized configurations that are running the desired software version, which is really the main goal of the initial provisioning steps there. Okay, so that ends our overview of the feature. Now we'll work through an example to provide some details of the objectives and the topology details here. So we're going to use ZTP to provision a QFX 5100 series switch. So we've got QFX1 shown here in the diagram. It has its GIGI 000 interface connected to a management network of sorts, where a DHCP and an FTP server exist. That server has the IP address of 172.25.10.1, and it is a /24 subnet. The DHCP service is configured with a pool as shown here on the slide, so .100 through .225, and we have a static assignment for the QFX1 switch based on its MAC address, the IRB.0 MAC address, and that assignment will map that device via that MAC address shown there to the 172.25.10.111 IP address. So understanding the factory default or the zeroized configuration is helpful to really understand what's going on behind the scenes with ZTP. So all revenue ports are associated with the default VLAN, has a VLAN ID of 1 on the QFX series. And the IRB.0 interface is also associated with that default VLAN. And in the factory default state, IRB.0 is configured as a DHCP client, which is required to help go through that initial phase of DHCP discovery and network discovery and getting added to the network. So with that in mind, let's go here. I have a couple sessions open, one to the QFX1 device and one to the DHCP server. The QFX1 device, again, we've identified the MAC address of IRB.0. Let's just re-verify that with the show interfaces IRB command, and here you can see about 6 or 7 lines down, you can see the line that has current address, hardware address. So that is the MAC address as shown there in the diagram of IRB.0. And Currently, we're running a configuration, hence the IP address on IRB.0 and the host name and the fact that we're logged in as lab. So what we've got to do to initiate the ZTP is simply boot this into the zeroized configuration. You can do that with the request system zeroize command, and then you've got to confirm that. That will go through and essentially clean out your current configuration as well as some log files. So we will confirm that, and that process will take a few minutes. It has to go through a reboot and kind of restart some factory default settings. So while that's taking place, you can see it's starting there. While that's going on in the background, let's go to the DHCP server here. And here, let's just verify that we've got DHCP and FTP, those services running. So let's just do a couple commands here. Service DHCPD status. And here we can see that DHCP is in fact running. And then let's verify FTP. VS FTPD. So here we see that DHCP and FTP are both running on this server. This is a CentOS server. So, and then let's verify the configuration, the DHCP configuration. Okay. So here at the top we have some details that are specific to the some vendor settings, vendor string settings, and subnet that we're serving addresses in. You can see the range here. So .100 through 225. We've got a few options set as far as the router, the gateway device, which is the server in this case, and the subnet mask. And then here's the option 43 details with the sub options, just kind of a reference to what we talked about in the first section of the Learning Byte. And then here we've defined two hosts. Of course, in this example we're only working with QFX1, and we've got the hardware Ethernet address specified, and that should match. Let me pull this over just a little bit. That should match the IRB MAC address as shown there on the diagram. So we've got DC38E1 5E4800, and then we're mapping that to the .111 IP address. Here we've got option 150, which again defines the FTP, or the storage server's IP address. So 172.25.10.1 as shown there on the diagram, that matches that device's address, or this device's that we're looking at's address. And then we've got some key options here in the form of the server image and this server file. So the server image, this is the software image. It shows the FTP path and then the image name here. So it looks like we're wanting the QFX1 device to be running the 13.2x51d21.1 domestic image. And then we've got a file stored again in that FTP path in the pub directory named QFX1-ZTP config. So in the background again over here with QFX1, it looks like it's rebooted. So at this point you should only be able to log in as root with no password. It's got that zeroized configuration in place. We'll just enter configuration mode. Now keep in mind that the ZTP process has been running in the background, so we may already be advanced to some point in the ZTP process. We'll wait just a moment here to see if anything pops up. So after a number of minutes there monitoring the screen, you should see some activity related to the ZTP processing. In this case, it verified that the software version running on the switch was the same, so it didn't need to go through an upgrade there. Ultimately, it moved on to the last phase and retrieved the ZTP configuration. It pulled that from the FTP server and then applied that. And as you can see here, we're back to the prompt, and in this case you should have noticed a change in the prompt. We went from root with no host name to root at QFX1-ZTP. So, and if I log out, I'm now forced to log in with a password. I'll stick with root. And there you see just some evidence that the configuration file is in place. Of course, you could also show configuration. We'll look at the system hierarchy. You can see that non-default values have been put in place, including an NTP server, a host name, user accounts, and the root password. So that concludes our Learning Byte on zero-touch provisioning. I hope you've enjoyed.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.